Hey everybody, going to do a few geometry problems with you here. Let's do a Menelaus theorem problem. Got one for you. You can see I've got a triangle called ACE, and I've got this red line, and I drew it in a dumb place. I can't complete my picture. This line, even though there's two units on each side, it's not an isosceles triangle. It's actually a right triangle. So that means that this red line will meet this bottom line AE at some point, at a point we're going to call F, but I don't even draw it. But what I'd like to do is find out how far away it is. I've called this distance X, that little red X there. Can we find out how far away that is? Well, it's obviously Menelaus theorem because you got a triangle with a line cutting through it. You can see this line's going to hit a third place, or at least right now we're going to show it does. But we need to get a distance for this spot. If we have two unknowns in one equation, even though it's linear, we won't be able to solve. So the big hint is I've got a side of length 4, I've got a side of length 5. It's a right triangle. So this side of length 5, since it's the hypotenuse, that forces this side to be 3. So I've got a 3, 4, 5 right triangle. We had to figure that out ourselves. Okay, now let's set up the Menelaus theorem. How about if I go AB over BC times CD over DE times EF over FA equals 1. Can I say that? Can I say that? I think I can say that, because the points B, D, and F are going to be collinear. They're all going to be on that red line. So let's pop in the numbers that we know. AB is 2. BC is 2. That cancels that fraction out. CD is 3. DE is 2. And EF is X. And then FA is X plus 3. That's all set equal to 1. So we can cancel out the 2 over 2 thing, and we can cross multiply and end up with 3x equals to 2x plus 6. Because 2 times 3 is 6. So subtracting 2x from each side, I have x equals 6. Now I actually did this thing in inches, which if you ever want to, just to make sure that you're doing stuff right, you can always build using a ruler and build it according to those measurements, and then your theoretical should be pretty close to your actual. It might not be right on. You might be a little bit off, but you can check that sort of thing. So that means that 6 inches out from here, and this is a 7-inch ruler, so 6 inches out from this spot, 6 inches further along is where these two things would meet. So this guy would come along there and meet here in the shadows. That looks good. All right. There's another question about on the wiki. How about some freehand stuff that you just take a picture of? Well, you know, the Menelaus theorem can fail. One of the ways Menelaus theorem can fail is this. Suppose you have, and I'm just freehanding this, but suppose I have a triangle that is 4 on this side and 6 on this side, and I mark a 2 and a 2. So this whole thing is 4. This whole thing is 4. There's a 6 on this side. Suppose I mark a 3 and a 3. And since it's a 4, 6, this other side, by triangle inequality, has to be bigger than 2 and smaller than 10. And it really doesn't matter what you make it. Call it 7. I don't care. But what's going to happen, and if you know your geometry, if you've been reading along, you're going to notice that this side, this little red segment, connects midpoints. The midpoints of both sides. So that is parallel to this, which means they'll never meet. So what happens if we pretend they meet? And I call this distance down here x. So it's the same as this problem, only this one actually has an answer. What happens if we try Menelaus theorem with something that literally won't work? Well, in this case, I already know that x is going to be non-existent. That if I try some math, the math should lead me to something incorrect. And that's actually a problem on this week's wiki, which closes in 3 hours. But anyway, Menelaus' theorem will also concur with the geometry that we know, that there is no x that's going to satisfy this particular one. Now let me spend the next few minutes teaching you how to make a lot of points this semester. There's going to be enormous opportunities to do constructions. There's a few on the wiki right now, and they will continue. Just construct a certain size. Construct something of a certain size. Well, I brought with me one of my compasses. This is not a cheap compass. I like this compass, though. It's a really good compass. I forget how much it costs, maybe $8 or $9 on eBay. It's a nice compass because you have the ability to change the size with great control. And here's what I really like about it. I can switch out the pencil. This is the pencil end. I can switch out the pencil with a little twist, pull this off, and I pop this thing on. It's a pen holder. You see it? Isn't that great? You pop this into the end, tighten it down, and then let's say I choose to go with a blue pen. I can stick a blue pen in here, and what's great about this is when you are preparing a drawing for publication on the wiki, the darker the colors, the better, because then we can see. So I'm ready to go. Now, in case you don't want to spend major bucks, there's a compass that you can get, a compass set. This is a Meyer Special, $3. And what you don't see is, because the tag covers it up, check it out. This guy is the bomb. Look at that. You can stick a pen in there. The only problem is this little metal screw is in a plastic ride. Eventually, it will run out of juice and not hold a pen anymore. But for now, you can stick a pen through there. You can stick a pencil, but you can change colors. You can make dark drawings. It's really nice. Now, it comes with this dinky little ruler, which might not be enough for you. And then a protractor, which we probably won't use too much. And then a 30-60-90 triangle and a 45-45-90 triangle, which you may use if you need to, but remember, you're not constructing when you use somebody else's example. $3. Not bad. All right, let's do the construction of the distance. 1 plus square root of 5 over 2. But I got to give myself a unit length, so I'm going to give myself a unit length. Now, if you're smart, you give yourself a unit length that is something that you can measure against later. So I'm going to give myself a unit length this much. There's my unit length. I'm going to count that as 1. Now I'm going to build a length that's 1 plus square root of 5 over 2, which is under 2 inches. But I'm going to have to construct a 5, and this is worth 1. So I'm going to work way down here, and I'm going to put a nice long segment in there that I hope is long enough for me to be able to construct this thing. Now let's lay down the strategy of what I'm going to do. This is right out of the book. If you have a segment of length 1, and then you continue along, and let's say here's what we're going to do. I'm going to put on a 5. So there's a 1 and a 5. You find the midpoint of this. Well, that adds up to 6. So you're going to find a distance of length 3. You make this semicircle. You go straight up from the 1. This distance right here will be square root of 5. That's right out of the book. That's what I'm going to do. I'm going to make square root of 5. And then once I have square root of 5, I'm going to add 1 to it. And then I'm going to cut it in half. I'm going to bisect it using the perpendicular bisector construction. So I'm going to do this square root construction right out of the book. And then add 1, which is easy. So let's get it and go. Here we go. I'm going to make this nice long line. I need a nice long line to work with. I hope it fits on this paper, because I got to mark out a total length. I got to mark out a total length of 6 of these, 1 of them and 5 more. So I come over here, and with my compass, I show the world that I copied this length. Check this out. Very important moment. Ta-da! Do you see? I copied that length. This is what's called a construction mark. I need to see your construction marks. That's how I grade you. All right, so let's mark them out. Count with me. 1, 2, 3, 4, 5. I need 6. So, you know what I do? I work on paper. And I'm going to just slip this piece of paper over here a little bit, give myself a little bit more room so I don't have to start over again. Get out my ruler and continue this line as carefully as I can for a little bit more length. All I needed was another little bit more. So that's a nice trick to have. Now you got to keep these two things together while you construct. All I needed was one more of these. And there's 6. Now I have to go a distance of halfway, which is 3. So technically I almost didn't need to do this thing because I could just work over here. So this is one unit, 2 unit, 3 units. This guy is halfway if I counted correctly. That's 3 units out of 6. This spot right here should be halfway. 1, 2, 3, 1, 2, 3. All right. So I'm going to do this, put the point of my compass there. Mark this thing out. I got to open it up pretty wide here to catch this end point. Whoops. You got to catch this end point. So I'm going to go from the 3 mark all the way to the 1 mark. Let's get it to show you how I fit that. Need a little bit more. Ooh, it's going to be wide. Here we go. It's just about there. Just a hair more. This looks pretty good. And here we go. All I really care about is going from the 3 mark along here. Looks pretty good. Let me continue it on the piece of paper there as best I can. And I really don't need that far end because I'm going to build my unit length. I'm going to build perpendicular to the unit length over at this end. The move is to build a perpendicular to this point, and this distance here will be square root of 5. So the perpendicular construction is pretty cool. All I need to do is make marks that are equidistant from the point where I want the perpendicular. Hey, I already have them. This point and this point are 1 unit away from this point. So I could put the point of my compass, you know, the pointy part, put it over here, make it more than halfway, and I'll make an X above that point where I'm going to do the perpendicular. Do you see? Okay, so I put the point of the compass here, made an arc, put the point of the compass here, made an arc. Where they meet is exactly the right spot to get that perpendicular. I'm going to make it red. That's another nice thing about doing your own constructions. All you need is a couple of colors of ink and you can make a gorgeous looking animal. So here we go. That distance right there is supposed to be the length square root of 5. Now, just to verify, it has to be longer than 2 because square root of 5 is 2 point something. So I'm just going to verify that it's more than 2. I know you can tell by looking that it is, but here's the length 2 units, and this thing is more than 2, but a lot less than 3. And the square root of 5 is more than 2, but a lot less than 3. Because square root of 5, square root of 6, square root of 7, square root of 8 all got to fit in between 2 and 3. So there you are. This is the thing. Now I'm going to do something that if I had been smart I would have done this earlier. I'm going to extend this because I got to put a 1 on the end of this so I can make 1 plus square root of 5. So I hope that's long enough. Now where am I going to get a 1 from? Well, I got 6 of them here and I've got 1 of them here. And I would never mark you off because your unit ended up bumping into your picture. You know, this is, you got to work on a piece of paper. You do the best you can. Now, I'm going to copy this thing. I'm going to get my compass set back to 1 again. 1 unit. There we go. Copying my 1 unit onto here. There we go. So this distance from my 2 fingertips, that distance is 1 plus the square root of 5. All I have to do is bisect this, and I have it. I have a distance that's 1 plus square root of 5 over 2. Well, that's the midpoint construction. So all I got to do is have my compass worth more than halfway of the distance that I want to get the midpoint of, and make an X on each side. Okay? And I come back over here to this other endpoint. Make a crossing of arcs on each side. And there we go. I'm going to draw the bisector. And what I really care about is this distance right there. That distance is 1 plus the square root of 5 over 2. And if that was your assignment, that's it. You've got the distance. Fits on one piece of paper. You take a picture of it, bam, put it on the wiki, maybe edit it down to be nice and trim. But we see the construction marks. You know what's important? I expect everybody in the class to be able to read something like this, like a book. And you say, okay, unit. Maybe you label this for the reader. Here's your unit length. Unit. Down here they say 1, 2, 3, 4, 5. There must have been a 6th over here. And if somebody, you know, puts a gun to your head and said, yeah, I did it all the way out even though I don't really need it. You know, I've got it all the way out. Or you choose a smaller unit so it fits on one piece of paper. So yeah, and then you found the midpoint to make this semicircle. That must have worked. And then you come up here, make that perpendicular. I see the marks for the perpendicular. And then I see you did one more unit above this thing. I see that mark and I know what that's for. I know what's that for. And you should know what it's for. What is that? That must have been for computing another unit onto this, because that's what we're doing, is 1 plus the square root of 5. So you have 1 plus the square root of 5, bisect it, that's 1 plus the square root of 5 over 2. I can read it. You should be able to read it. That's 16 minutes, you guys. See you in school or not. Bye-bye.